Algebra 2, 5-3, polynomial functions. So we're going to draw a little chart here, and then we're going to do some examples. So we got a polynomial. We've got an expression, degree, and leading coefficient. And so we'll see how much explaining I need to do, but as we fill this chart out, hopefully these definitions are going to kind of become clear. So first polynomial is just a constant. And a constant is just a number, like the number 12. It's got a degree of 0, and the leading coefficient is 12. A linear polynomial looks something like this, 4x minus 9, or it would be y equals 4x plus 9, but this is just the expression, so it's not an equation. 4x plus 9, or minus 9, 9 would be your y-intercept, 4 would be your slope. The degree here, x is to the degree of 1, and the leading coefficient here is 4. That's the number next to the variable that has the highest or greatest degree. Quadratic. This is something like 5x squared minus 6x minus 9. The degree here is 2, and the leading coefficient is 5. Cubic. This might look like this, 8x cubed plus 12x squared minus 3x plus 1. The degree is 3, the greatest degree of the variable. And the number next to that was the leading coefficient, and that is 8. And then we have kind of a general rule here that is kind of messy. So I have a with the sub n there times x to the n power plus a n minus 1 times x n minus 1 dot 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 a1 x plus a0. So there could be a whole bunch in between here, minus 2, minus 3, minus 4. So the degree is this number here, the greatest power, and then the coefficient, the leading coefficient next to that greatest power is a sub n. All right, so here's a non-example. We just have one of these. This is not a polynomial. 5x cubed minus 4x squared minus 8x, just 8x, plus 4 over x. This is your problem right here. Not a polynomial. All right, let's do some examples now. Find, this is kind of a new subject, find 3c minus 4 minus 5 f of c. So I've got find f of 3c minus 4 minus 5 times f of c if f of x equals x squared plus 2x minus 3. Okay, here's how we do this. We take this here and we plug it in for all of the x values. and we take this here and we plug it in for all of the x values. And we multiply that mess by negative 5. Let's see what I'm talking about here. So we're going to look at these two separately for right now. Let's do this one first. So this is x squared, so I just plug this in for x. So 3c minus 4 goes in for x. 3c minus 4 squared plus 2 times 3c minus 4 minus 3. So I've just plugged in this value for x in this equation, in this function. Now I need to take care of this mess. So I have minus 5 times, I just plug c in for these x values, c squared plus 2c minus 3. And that's all there is to it. Now we just need to simplify this huge mess. So now I can't just distribute this squared. I have to FOIL this. This is 3c minus 4 times 3c minus 4. That's what this is. I've got to split that up like that. But I can simplify here. I'm going to distribute this 2. So this 2 goes in here. Plus 6c minus 8 minus 3. I'm going to distribute this negative 5. Minus 5c squared minus 10c plus 15. So I just distributed that negative 5 throughout there. Now I need to take care of this FOIL here. So 3c times 3c is 9c squared. 3c times negative 4 is negative 12c. Negative 4 times 3c is another negative 12c. And then I've got negative 4 times negative 4 is positive 16. I'm just going to write the rest of this out here. Plus 6c minus 8 minus 3 minus 5c squared minus 10c plus 15. Now I'm going to combine like terms. So like terms are the same variable raised to the same power. I can combine those. Anything that's not the same variable with the same power, I cannot combine those. So let's look for all of the c squareds first. I don't see any more until I get right there. Those are the c squareds, so I'm going to combine those. Positive 9, negative 5 gets me positive 4c squared. Now I'm going to look at the c's. Okay, negative 12 and negative 12 is negative 24. Plus 6, that gives me negative 18. Negative 18 minus 10 is negative 28. All right, so I might cross these off just to help me not see them anymore. And then the rest, I just have constants. So I've got 16 minus 8, which is 8, minus 3, which is 5, plus 15 is 20. And there's my answer. All right, let's see if you guys can do this. G of 5a minus 2 plus 3 times g of 2a. If g of x equals x squared minus 5x plus 8. So just do what we just did, but with these values. All right, go ahead and pause and get to work. Welcome back. Let's try this out. So I'm just going to plug this in for my x values here. So 5a minus 2 squared minus 5 times 5a minus 2 plus 8. So now I've taken care of this mess. Now I need this one. So I need to say plus 3 times 2a squared. I gotta go like this, 2a squared minus 5 times 2a plus 8 Oops. There we go. All right. So this is going to be 5a minus 2 times 5a minus 2. 5a minus 2 times 5a minus 2 minus 5 times 5, which is 25a, plus 5 times, negative 5 times negative 2 is positive 10, plus 8, plus, now I'm going to do this here, 2a squared is 4a squared. 2 squared and a squared. Since I'm multiplying these, I distribute the power. So I'm going to say 3 times 4a squared is 12a squared. 3 times negative 5, oh, let's multiply these two here as well. So that's negative 10a. 3 times negative 10 is negative 30a. And then 3 times 8 is positive 24. All right, I'm almost ready to combine like terms here. 5a times 5a is 25a squared. Negative 2 times 5a is negative 10a. And then also 5a times negative 2, negative 10a again. And then negative 2 times negative 2 is positive 4. And I can write all this out again, why not? 25a plus 10 plus 8 plus 12a squared minus 30a plus 24. All right, now let's combine like terms. I've got 25a squared and I've got 12a squared. I don't see any more a squareds, so that'll give me 37a squared. And I'm going to cross those out. And then I've got negative 10a and negative 10a, that's negative 20a, minus 25, so that's negative 45a, minus 30, that'll give me negative 45 minus 30 is negative 75a. So I've done all of those. Now I'm going to look at all of the numbers that don't have a variable. 4 plus 10 is 14, plus 8 is 22, plus 24 is 46. And I have, and I'm all done. There's nothing I can do to that. All right, I'm going to give you one more try. And then we're going to look at some more of this. Some different stuff. B of 2x minus 1 minus 3 times b of x if b of m equals 2m squared plus m minus 1. All right, go ahead and pause and do this one, then we'll do it together. Go. All right, let's see how you did. 2m squared, so this is going to go in for the substitute for the m value, and then this is going to substitute for the m value as well. Let's do this one first. 2 times 2x minus 1 squared plus m, which is going to be 2x minus 1 minus 1. Now I'm going to take care of this part. Minus 3 times I'm just plugging in that x, so I don't need brackets. I can just do regular parentheses. 2x squared plus x minus 1. So I've just substituted x in for m, and I've substituted 2x minus 1 in for m. So now I just need to simplify all of this. 2 times, this is 2x minus 1 times 2x minus 1. So I'm just going to do that right here. 2x times 2x is 4x squared. Negative 1 times 2x is negative 2x. 2x times negative 1 is negative 2x. Negative 1 times negative 1 is positive 1. All right, so I've taken care of that. Now I have 2 plus 2x minus 1 minus 1. and then I'm going to distribute this negative 3, negative 6x squared, negative 3x, positive 3. All right, negative 2x and negative 2x is negative 4x. Now I can distribute this 2 in there, and I've got 8x squared minus 8x plus 2 plus 2x minus 1 minus 1. I'm just going to go ahead and say that's minus 2. Minus 6x squared minus 3x plus 3. Okay, I've got an x squared here, I've got an x squared here, positive 8x squared, negative 6x squared, positive 2x squared. Then I've got negative 8x, positive 2x, negative 3x. So negative 8x and 2x is 6x minus 3x. Let's see, so I've got negative 6x minus 3x, negative 9x. So those go away. And then I've got negative 2, that's 0, plus 3, I got plus 3. Whew. All right, so those can be a little bit tricky. Now let's keep moving though. We're going to look at graphs of polynomial functions. And we're just going to draw. So we've got all of these different functions here that we looked at the beginning, and we're going to see what each of those looks like as a graph. So we've got a constant. We have a linear and a quadratic. I'm going to leave some space, and we're going to do a cubic and a quartic and a quintic or quintic. So these are ones that we didn't list. Also, we're going to look at even degree, and odd degree. All right, let's draw some graphs. So these are just examples of what one might look like. So remember, constant has a degree of 0. And if I have a graph, my coordinate plane, a constant is going to look like this, like y equals positive 3, or positive 2 here. So let's just say, for an example, y equals positive 2. 3. Okay, either way, doesn't matter. That's constant, just a line that's flat, that has 0 slope. Linear, remember, has a degree of 1. Here's my coordinate plane. A linear line would look something like that. It doesn't curve, it's just straight. Quadratic has a degree of 2. And this looks something like this. It might open up, it might open down, but it's going to be a parabola. Cubic has a degree of 3. And that's going to look something like this. It's going to go up, going to go down a little bit, and then go back up. Quartic has a degree of 4. That's going to look something like this. Starts up, comes down, goes back up again, goes back down again, goes back up again. Quintic has a degree of 5. And it looks something like this. Start low, come up, down, up, down, up again. Now, notice something here. If it is an even degree, notice how the arrows are going to be going the same direction, as in up or down. They're going to be going either, both of them are going to be going up, or both of them are going to be going down. If the degree is odd, then one arrow is going to be going down and one is going to be going up. So an even degree polynomial is going to be going one direction and then going back that same direction. Technically, I'm probably saying it not quite accurately, but it doesn't matter. You get the idea. So an odd one is going to be coming from one direction, and it's going to go down. Like if it starts going from up, then it's going to go down. If it starts from down, it's going to go up. All right. Now, here's an example. So if I have a graph that looks like this, coming from up here, down, up, down. We're going to talk about end behavior. And we're going to say when x goes to negative infinity, f of x goes to infinity. And here's what I mean by that. If our x values, if we start plugging in x values that go to the left, toward negative infinity, that way, to the left, then f of x, or my y values, are going to be going up and up and up and up to infinity, positive. When x is going to positive infinity, so if we were to plug in x values here, going to positive infinity, then f of x, or my y values, are going to negative infinity. Is this an odd or even degree? Odd or even degree. This one's got to be an odd degree because it goes one direction and then goes the other direction. So this is odd. And then we can say, how many real zeros are there? And a real zero, hopefully you remember, that's where the graph crosses the x-axis, where it goes through or touches the x-axis. And so it goes through 1, 2, 3 times through the x-axis. All right, let's have you do one. So we've got a parabola that's going down like this. So I want to know the end behavior. I want to know, is this odd or even degree? And I want to know how many real zeros are there. All right, go ahead and pause the video and try to do this you-try. Okay, let's see how you did. End behavior. So I'm looking at here, if I were to plug in negative x values, so as x goes to negative infinity, I'm plugging in x values here all the way to negative infinity, my arrow is going down, so that means f of x is going also to negative infinity. As x goes to positive infinity, if x values are, I plug in to the right, f of x is going down, so f of x is going to negative infinity as well. Now, since my arrows are both pointing down, I know this is an even degree, and I can see that this graph goes through the x-axis in 2 spots, so I have 2 real zeros. And that is 5-3. Good luck on the homework.